If you don't know about the fractal universe, and only know about relativity, quantum mechanics, and all the other standard models, then you are definitely missing out. Journey with us into creation and the universe as we unveil the cosmic symphony of the fractal universe. Prepare to dive into the mesmerizing depths of the golden ratio fractal universe, a realm where Fibonacci patterns echo across every conceivable scale, from the grandeur of galaxies to the intricacy of every living organism, and the molecules and subatomic particles found within them. In this cosmic tale, we'll decipher the secrets of the self-similarities, vibrations, oscillations, and resonances that bridge the realms of mathematics, biology, physics, and chemistry. For the uninitiated, the concept of a fractal may seem elusive. Imagine a sequence of geometric enigmas, vibrations, and patterns within a structure that endlessly repeats its unique designs or orientation, whether you zoom in or out. Now ponder this. Could the very universe we inhabit be entwined in a similar cosmic dance, echoing patterns from the tiniest particles to the grandest galaxies? Look closer and you'll discern an astonishing truth. Stars, those celestial giants, are not so different from the galaxies they inhabit, as they strive for the same cosmic alignment and energy synchronicity, but just on a smaller scale. Moons, too, mirror this pattern, as the humble offspring of the planets they orbit. Planets, in their own right, echo the attributes of their parent stars, with some planets hosting elaborate planet-wide convection mechanisms, and nuclear cores that burn with a thermodynamic churning of fiery energy and magnetism. But how do we substantiate these claims of cosmic reverberations and repeated patterns? The evidence unfolds not through the eyes of Einstein, but through the eyes of Edwin Hubble and the latest marvels of early massive galaxies unearthed by the James Webb Space Telescope, which unexpectedly revealed galaxies so ancient and massive that they defy our conventional understanding of the cosmos and challenge the very fabric of the most widely accepted theories. The James Webb Telescope is our guide to these celestial wonders. It unveils galaxies that shouldn't exist, catapulting us beyond the boundaries of established knowledge. Yet, there exists a prophetic theory predating all others, crafted by the visionary Edwin Hubble himself. His theory demands that the earliest galaxies be the largest, the most dynamic, and the most energetic. Fundamentally, the essence of the universe, from the grandest galaxies to the tiniest particles, yearns to be a superposition of three fundamental states, which are contraction, expansion, or equilibrium. These three states can also be seen across the entirety of the physical existence of the universe in the form of attraction, repulsion, or neutral, hot, cold, or moderate, negative, positive, or neutral, on, off, or null, 1, 0, or null, past, future, present, or now, and so on. These states, and the direct oscillation between these states, or the sequencing of these states, gave birth to matter, energy, and even the rudiments of consciousness and choice across the cosmos, where the threads of consciousness are intertwined within the notion of information and possibilities, which have been woven into the tapestry of the physical existence of the universe. So to move beyond the broad notions of gravity, matter, mass, and energy, it is necessary to peer into the building blocks of information and consciousness, but we will get back to that later. Essentially, at the universe's birth, a superposition of three possibilities hung in the balance: contraction, stasis, or expansion. The explosion or expansion we now recognize as the Big Bang was the undeniable choice. At the start of the universe, there existed a singular object which held the entirety of the cosmos. The universe's entire finite supply of gravity, energy, matter, information, and even consciousness was contained or confined within this one structure. Somehow, every word yet spoken, and every atom yet reacted, were all contained and confined within that singular point. So, some 13 billion years ago, our universe consisted of one entity that was three things all at once, or a trinity, and the three competing states were: 1. An endless void of nothingness. 2. A singular point that cradled all mass, all gravity, all consciousness, and all energy. And or 3. The homogeneous stoic equilibrium of nothingness and a vibrating, reverberating cauldron of everything simultaneously. As such, according to Edwin Hubble's profound insight, immediately after the Big Bang, the universe's earliest vestiges wasn't an endlessly dispersed sea of inert hydrogen atoms, but a teeming symphony of colossal clusters of elliptical galaxies, overloaded and bursting at the seams with energy and entropy. These fantastical galactic giants eventually fractured, birthing the initial phase of somewhat organized galactic clusters and elliptical galaxies of the size predicted by Edwin Hubble, and that we now observe with the James Webb telescope. So it was never about puffy nebula-sized clouds of hydrogen, but about massive elliptical galaxies that happen to resemble fuzzy clouds, but were actually somewhat disorganized swarms of massive stars held together by gravity. As these colossal storms or swarms of colliding stars gain rotational momentum, and their overly packed galactic centers continue to get overloaded with energy, these initial phases of galaxies are what would ultimately transform into quasars. In the fractal tapestry of the universe, quasars mark the transition from massive elliptical galaxies to stable spiral galaxies, which is known as the Edwin Hubble Galactic Tuning Fork model. This transition mirrors the life cycle of stars, akin to pulsars, which are one type of solar structure or system that can emerge when massive stars become very unstable. Thus, from the root cause of the Big Bang emerged a cosmic and galactic tree, with many stellar branches and leaves, or maybe we could say there emerged a cosmic onion of many fractals, such that directly after the Big Bang's singular structure came the emergence of many massive globular clusters. Then came elliptical galaxies, quasars, dwarf galaxies, spiral galaxies, massive stars, pulsars, main sequence stars, and brown dwarf, with gas giants, rocky planets, asteroid belts, moons, and planetary rings, being the most recent and smallest structures to emerge. Nonetheless, a single gas giant and its many dozens of moons and planetary rings is simply a miniature version of a solar system. And a solar system, with its many planets, hot gas giants, or binary pairs, is just a miniature version of a galaxy. As such, building on Edwin Hubble's tuning fork model, planets, rather than being formed from the collision of inert clouds of dust and gas, would necessarily be born from plasma droplets expelled from very unstable stars that were transitioning into a new solar phase. And this would also necessarily mean that unstable stars do not only expel jets and flares, but on occasion produce massive ejection events, with solar winds containing actual plasma material that the star's gravity cannot hold down. Essentially, when a large enough bulb of material is violently ejected from a star's structure, this is what typically settles into a stable orbital path around the star, and becomes a planet, which remains gravitationally in tow, as the star continues to traverse across its own home galaxy. Consequently, the planets formed within a solar system would be based directly on the star's chemical composition and rotational inertia, or angular momentum, as each solar droplet would be imbued with a rich mix of chemicals and particles, and would also be imbued with enough angular momentum to remain synchronized with the stabilized star that has successfully completed its solar transition and sits at the center of this newly expanded planetary system. In other words, as these plasma droplets journey away from the star, or settle along stable prograde equatorial orbitals around their parent star, they would cool into the planets we now observe, preserving their unique chemical makeup and the delicate balance of the overall synchronicity of the system. Therefore, the stars that we observe going supernova, or that become pulsars, do not simply implode into infinitesimal nothingness. Instead, they are simply at the start of a new phase of stellar evolution, and the exoplanetary systems that we observe as multi-star binary systems, or as hot Jupiter systems, with large gas giants orbiting so close to their parent star that they are basically touching, are simply the systems that emerge after those initial phases of violent events. Eventually, the planets themselves in those systems will continue to erupt violently to create their own initial set of moons and/or planetary rings, as they move outward away from the still unstable star. And just like their parent star, ultimately they will all stabilize and settle into prograde equatorial orbits, which is the stage of stellar evolution that most closely matches our own home solar system, where all our gas giants have cooled and have moved further away from the parent star of the system, and a second phase of plasma droplets eventually emerged from the star. In time, those smaller droplets too cooled to become the rocky planets that we now observe located somewhat close to the Sun, and at least one of those planets, which we call Earth, was able to successfully induce and sustain the emergence of living biological life. At this stage, you must be asking, where does consciousness now fit into this cosmic, galactic, celestial, or biological fractal puzzle? Recent scientific discoveries have revealed the presence of complex organic molecules in distant galaxies, which implies that solar systems or star systems across the wider universe have always had the potential for organic synthesis from the very start of the physical universe. The emergence of biological life, in this context, hinges on the precise interplay of energy transference imbued within a planet from its parent star, and the diversity of chemical elements, or the enriched isotopic or ionic mixtures of chemical elements that over time emanate from the planet's core and/or deepest interior. Therefore, it is best to forget the notion of the cradle of life as a primordial soup, or as a mere puddle of stagnant liquids on the surface of the planet. Instead, this new perspective takes you on a deep dive way beyond primordial lakes, rivers, and streams, and even far below the ocean's hydrothermal vents, into the very mantle and core of the planet. Here, at these geophysical depths, the secrets of life's birth are encoded in specific nuclear reactions, and not just in mere chemical reactions. Essentially, the creation of life is a tale of geochemical, celestial, and cosmic alchemy. Therefore, in the grand cosmic symphony, the emergence of biological life on a planet isn't a matter of happenstance, nor does it stem from random comets or asteroids falling from the heavens. No, the genesis of life is a breathtaking interplay of energies and precisely orchestrated chemical elements, rising from the planet's hidden depths to the surface. Picture a universe where only select planets possess the resources and conditions necessary to ignite the delicate dance of life. This cosmic process demands a unique blend of nuclear reactions, where fission and fusion are not the stars of the show. Instead, PN, knockout reactions, along with the subtleties of beta and positron decay, take the lead. But here's where the tale takes a thrilling twist. Deep within the planet's core, you won't find a monotonous sphere of iron, nickel, and cobalt that just exists as a magnetic dynamo. No, the planet's core is a seething cauldron of elements, stripped of their electrons, locked in a perpetual ballet of nuclear transformation and transmutation. This is where the magic would unfold, as the planet would maintain its production of the lightest gaseous elements from the periodic table, specifically through nuclear transmutation. Essentially, within this model, the planet's core isn't a monolithic mass of iron, nickel, and cobalt. Instead, many of the deepest layers within the planet would be a dynamic mix of elements, stripped of most, if not all, of their electrons. Deep within the planet's structure, imagine the vast quantities of high-speed protons and naked atomic nuclei, completely stripped of their electrons, that would be present due to the planet's excessively high internal thermal energy. Additionally, imagine how these same charged particles would necessarily be accelerated and guided by the planet's own magnetic field, which cumulatively would actively ignite, induce, and maintain the forging processes of the ionic and isotopic ingredients needed for the spark of the creation of life. Unlike the hefty alpha particles or helium nuclei, which are necessary for the fission and fusion processes associated with stars, the nimbleness of protons, aka hydrogen nuclei, within the interior of the planet would make hydrogen nuclei the maestros, or the most important component in the life creation process. So, for a planet to conduct nuclear reactions, it's not about the usual suspects like fission or fusion reactions. Instead, think beta and positron decay along with PN, knockout reactions, as the latter require far less energy or enriched ingredients, and are instead more like the subtle nuclear changes that are akin to the processes behind spent nuclear rods, PET scans, or the synthesis of fast-decaying isotopic materials in nuclear reactors and particle accelerators, which can simply be powered by high-speed protons or stripped-down hydrogen nuclei accelerated by magnetic fields, without necessarily being reliant on alpha particles or helium nuclei. Thus, within such a planet's deepest interior, there would be constant isotopic changes, or nuclear transmutations, occurring, due to the intense frictional collisions taking place among those highly charged ions and atomic nuclei. As such, within this fractal planetary model, where planets can operate somewhat like stars, the intricate dance would lead to the release of a multitude of loose protons and neutrons, turning the planet's deepest interior into a hotbed of high-energy hydrogen nuclei colliding with many other atomic nuclei, which would lead to the exponential production of even more isotopes of various elements, as well as vast quantities of hydrogen or free protons and free electrons. Eventually, over time, convection currents would ferry these hydrogen ions and other isotopic material upward, enriching the mantle, crust, surface, and atmosphere of the planet with a diverse blend of chemical elements and isotopes, in the form of various stable and non-radioactive chemical compounds made specifically from hydrogen, nitrogen, oxygen, carbon, aluminum, magnesium, calcium, sulfur, phosphorus, and so on. Thus, imagine the differential distribution of elements within the planet's structure, where lighter elements, mainly gases, would rise toward the upper layers to dissipate heat and excess energy taken from the planet's deepest interior via convection, while heavier elements, predominantly metals and heavy radioactive atoms, would gravitate toward the core, leading it to indeed eventually resemble a ball of mainly iron, nickel, and cobalt. In essence, the type of planet that can successfully create biological life is the type of planet that can use various convection and thermodynamic processes to act as a miniature version of a star that have a cyclotron core and not necessarily a fully nuclear core, and is also the type of planet that can wrap itself in a thick planet-wide atmosphere that the planet itself generated without having all of its gaseous elements evaporate away into space, but instead have it all constantly being replenished, recaptured, and accumulated first as clouds, then as liquids, and later as ice in various geological depressions across the planet's surface. So, these types of planets acting as miniature stars would possess the energy and the means to facilitate the eventual creation and stockpiling of the chemical infrastructure, chemical information, and chemical ingredients necessary for the sustained creation of life. As such, deep within the structure of the early Earth, when the planet was exiting its plasma phase, and thus was fully molten, certain grouping of elements would have been forced to transition into various isotopes of each other. But elements like nickel, cobalt, and iron in the fourth row of the periodic table would remain mostly unchanged, where nickel-62 and Fe-56 exist as the most stable nuclei that can exist in the physical universe. And because of this fact, most of the heaviest elements that break down or decay over billions of years would eventually lose enough protons and neutrons to specifically become nickel, cobalt, or iron. However, in the third row of the periodic table, elements such as sulfur, phosphorus, silicon, aluminum, and magnesium would not be immune to the transmutation processes, and instead would be converted into various isotopes of each other. Furthermore, even lighter elements such as carbon, nitrogen, and oxygen in the second row of the periodic table would be systematically transformed into isotopes of each other. And this is because almost all elements can undergo PN, knockout reaction, and beta decay, as shown in the modern-day processing of isotopic materials for positron emission tomography (PET) scans. So, although most gaseous elements do not readily undergo nuclear fission reactions and are typically deemed to be somewhat stable, they are just not as atomically stable or as tightly packed as the nuclei of iron and nickel. As a result of this, most of the different groupings of elements and their isotopes that were transmuted within the planet's deepest interior have now become the most abundant elements present within the Earth's crust and atmosphere, and are even abundant within the structure of the Moon, which split directly from the Earth at some point in the past, when the planet was still in a completely molten or plasma state. Additionally, this process is what makes both Moon and Earth rocks distinctly different from asteroids, as most asteroids and meteors are largely made up of visible veins of pure metals, and they possess isotopic ratios of certain elements that, although close, are still not a perfect match for anything that is found on the Earth. Hence, nitrogen, acquired from transmuted oxygen, is now the most abundant element in the Earth's atmosphere, even though oxygen is the second most abundant element on the planet. Plus, the planet's atmosphere is now awash with a very precise and distinct ratio of carbon-14 isotopes, which is what makes it possible to carbon date various things. Consequently, the type of geothermal mechanisms and alchemical processes within the Earth's structure that successfully and continuously transmuted oxygen into nitrogen and hydrogen, or even nitrogen into carbon and hydrogen, are the exact types of energy exchanges that would have laid the groundwork for the first synthesis of simple organic molecules, and then on to complex polymers, which would eventually lead to the creation of the first distinct forms of carbon-based biological life, especially once the planet's thermal energy output had decreased significantly and no longer caused thermolysis, or broke any molecular bonds, or stripped any atoms of their electrons. So, leading from the Big Bang, then to massive energetic galaxies, then onto stars and planets, that together form stable solar systems. It is only at this fractal stage, among carbon-based molecules, molecular structures, or living biological organisms, on these planets, would the energy and information brought over or carried along from the genesis of the universe find a haven for reliable storage, confinement, refinement, and translation. In other words, after billions of years, it is only now, with the existence of living organisms, that the universe can once again cognitively observe itself. Therefore, as part of an abstract, esoteric, or metaphysical philosophical argument, it could be said that we, as living beings, are the universe experiencing itself, over and over again, within itself. Furthermore, with this intricate story about fractals being designed and written, and the audience attentively listening to it, or watching it in its entirety, then those actions themselves is a part of the universe finding out for itself how it came to be, and what sequences of information and consecutive possibilities unfolded, to allow these observers and translators to come to be. Even though each living being's particular unique existence and unique experiences ultimately only account for a microsecond and a minuscule ripple when compared to the true age and size of the physical universe. To go even deeper, perhaps, the only other time another set of biological living beings might have somehow figured all this stuff out in these precise sequential order was not during the time of Einstein or the time of Aristotle, but might have been billions of years ago on some distant world, in some distant galaxy at the far corner of the universe. But that particular alien civilization, or even its entire solar system and home galaxy, have since then long been extinguished from the cosmos, and have returned back to the reverberations of the fractal energy cycle of the universe, from whence they came. Essentially, from the universe's very beginning, it was marred by volatile energy and gravitational pockets, transitioning from massive galaxies through to the emergence of spiral galaxies and stars, all of which were marked by violent transitions via quasars, supernovas, and pulsars. So it is only now, give or take a few billion years, with the existence of planets, and to a lesser extent moons, that the universe finds itself cool enough and chemically stable enough to create and sustain a single continuous living biological molecule that can exist uninterrupted for billions of years. On the planet Earth, DNA was the only resonant molecular structure, information pathway, or geometrical pattern to successfully unlock the fragments of consciousness and sentience encoded within the fractal universe, where DNA is the only molecule that is continuously being replenished, replicated, and added to for billions of years. But most of us fail to realize that DNA is not like a piece of paper that was only written on once, that then lay unchanged, or that regress and degrade into nothingness. Instead, DNA should be seen as a vast, unbroken, and uninterrupted computer code, more like a digital operating system, that is actively being edited and continuously re-uploaded for billions of years. Although individual organisms die, and their specific unique DNA sequence quickly ends, their surviving offspring still continue to carry a part of their code, and so the code never has to restart from gene 1, it simply continues to exist, as swaths of codes are removed, replaced, or reintroduced. This is the reason why mitochondrial DNA in some cases can be passed on across thousands of generations, specifically via female offspring, for millions of years, as proven by the out-of-Africa theory, which definitively points to Africa as the birthplace of the human species using mitochondrial DNA. Similarly, vestigial genes or ancestral genetic code can be preserved within DNA, such that some remnant or dormant code for extra appendages and extra organs, like tails and gills, can still be carried over from the ancestors who, for billions of years in the past, may have lived in rivers, seas, or oceans. Essentially, the key is to consider DNA and all such sequences of organic molecules not just as the building blocks of life, but also as the algorithmic operating system that amalgamate molecular structures and drive all biological processes involving the interactions among RNA, enzymes, lipids, and proteins, which all stem from the resonance repository of the null states and on and off states of atoms and molecular instructions, much like the atoms and molecules themselves emerge from the interplay of negative, positive, and neutral subatomic particles. Therefore, within the context of fractals, all the interactions among ions, atoms, atoms, molecules, organelles, cells, and organs within all organisms, at the most basic levels, should be seen as very similar to how the electrons, current or power supply, or the on and off of transistors and capacitors, stringed together, can determine the ones and zeros of a computer. So, man-made computers function via static electrical components, but the chemical power supply, information, and functionality found within living organisms come in the form of ions and molecules suspended within various molecular structures or chemical solutions. But unlike the silicon and copper microchips and circuit boards of man-made computers that can only interpret or utilize electrical signals, the living biological circuits of an organism can detangle and interpolate the essential forces and states that govern the physical universe, which include gravity, magnetism, mass, matter, energy, charges, particles, vibrations, oscillation, resonance, light, darkness, information, and consciousness. As such, it is the intricate sequences of these states and forces, specifically the intricate combinations of matter, mass, and energy within the universe, that give rise to complex structures and sentient life, capable of harboring, harvesting, interpreting, and storing information, decisions, and choices. By combining sequences of large gravitational structures, the fractal universe can create galaxies, but by connecting sequences of magnetic or charged particles, the fractal universe can create living beings, allowing the universe to harness its own energy and information to look back at itself. Therefore, it is clear that this cosmic dance of numbers, patterns, and mathematics that echoes and reverberates throughout the universe is entwined with the golden ratio Fibonacci sequence. It orchestrates the birth of galaxies, the intricate beauty of nature, and the complexity of living organisms. All of this emerges from energy pockets and information confined within the universe, governed by its unyielding physical laws. So, as we contemplate the mysteries of life, gravity, matter, energy, and consciousness, remember the profound connections between the universe's grandeur and the delicate beauty of nature and existence, confined within the fractal structures that exist throughout the universe, and the unwavering patterns, vibrations, and resonances that repeats across all scales.